Had my mic off there for a second. Welcome to another live stream. This one's going to be slightly different. Instead of doing a capture the flag, I'm also going to be doing other things as well, such as creating projects. So this project that I'm going to build is going to be an autonomous red team assistant. So also known as a Sentinel-Agent. So the goal of this project is to bridge the gap between raw data and actionable intelligence. And the tech we'll be using is Python, Nmap, scripting engine, and local LLMs, language learning models such as Llama 3, Mistral, via Ollama. And the mission is that most security scans provide a list of versions but no context. Sentinel-Agent uses Agentic AI to interpret scan results, identify likely CVEs in real time, and suggest manual exploitation paths, all while keeping the data 100% local and private. So CVE stands for Common Vulnerabilities and Exposures. And this is probably the start. This is probably going to be an overview of what will probably be a 15 to 20 episode series building this project. My estimation is that it will take around 40 to 60 hours to complete. But once it's done, I'm hoping to add it to my portfolio. And by live streaming and recording, I'm hoping to make it so that you yourselves watching this, whoever watches this, I don't know if anyone will watch this, but you can also replicate this as well for yourselves. So I'll split this into, autonomous red team assistant. I'll split this into 4 phases. The first phase will be the core engine, and what will be entailed is the architect, project setup, parser, the brain, the system prompt, the first live run. So all this, each line is probably 1 episode. So this is about a 5-step episode for the first part. Today we will just be looking at the project setup, Nmap, Python integration, and environment hardening. But I've also got other phases coming as well. So phase 2 will be the intelligence and depth, which will be CVE lookup integration, the hallucination filter, automated payload gen, model battle, the reporting engine, and chain of thought. For phase 3 will be agentic autonomy. So chain of thought, the recon agent, the web agent, memory and state, the ethics gate. And phase 4 will be professional polish and development. So the dashboard, optimizing for speed, the gold standard, code review and refactoring, and the final showcase. So I'm pretty excited. I've never done anything like this before, but hey, I'm pretty keen to get into it. I have no idea what it's going to look like, but I think that's why I'm getting out of my comfort zone and trying these sort of things. So I've got about 1 hour today, maybe more like 45 minutes. I'm trying to get the first dot point done. And yeah, I think I also wanted to make it just so as an overview for people to know what's to come in this project. It'll definitely be a playlist. That's the plan. Anyway, time to get to work. So the first thing that we're going to do today is the environment lock-in. We're going to create a clean room for this project. So the command that we just ran was done to create a contained laboratory for the project. It ensured that whatever libraries or tools that we install for this project doesn't interfere with the computer's main Python setup or other assignments. So the syntax is that Python calls the Python interpreter. -m, this flag stands for module, and it tells Python to run a specific library module as a script. venv, the first one, this is the name of the built-in Python module that handles virtual environments. So virtual environment, the second one, is the name of the folder we're creating. While we can technically name it anything, VENV is the industry standard. While this is necessary, without a virtual environment, every library we install with pip goes into a global folder. If project A needs library X version 1.0 and project B needs library X version 2.0, the system will break. By using VENV, virtual environment, your isolation, your Sentinel-Agent dependencies like Python Nmap stay inside the folder. Portability, you can generate a list of your specific tools, a requirement.txt file, so someone else can recreate your exact environment. And safety, you won't accidentally break your operating system's internal Python tools. So now we've built it, now we need to activate it. On Linux, the command is source venv /bin /activate. Otherwise, on Windows, it's just venv /scripts, with a capital S /activate. Okay, and now we are going to install the essentials. Installing the essentials means downloading the foundational building blocks libraries that allow your Python code to interact with external tools. Without these, your script is just a text file. With them, it gains the power to scan networks and think using AI. Okay. When you run pip install, you're using Python's package manager to go to a massive online warehouse, PYPI, and download pre-written code. Efficiency. Instead of writing thousands of lines of code to handle network packets or AI neural networks from scratch, you import the networks others have already done. Dependency management ensures that your project has the specific tools it needs to run neatly tucked away in that virtual environment that you just created. The I's, Python-Nmap. You are already familiar with Nmap as a command line tool for network discovery. The wrapper, Python Nmap is a wrapper. It acts as a translator between Python and Nmap program installed on your Kali Linux system. It allows your Python script to start a scan, wait for it to finish, and then receive the results as a Python dictionary that your script can easily read and manipulate. Ollama is a game changer for developers working with AI. It is an open source platform that allows you to run large language models like Llama 3 or Mistral locally on your own hardware. Why use Ollama for your red team assistant? Privacy and security. Since you're a cybersecurity student focused on penetration testing, you don't want to send sensitive data, scan data, or potential exploit paths to a cloud provider like OpenAI. Ollama keeps everything on your machine. It's completely free to use. You aren't paying per request fees, and the Python library. By running pip install Ollama, you are installing the specific connector that lets your script send prompts, questions to the AI, and get back responses. Vulnerability analysis, nice. So essentially, Python Nmap runs the scan to find open ports and service versions. The script that we will make cleans up that data, and Ollama receives that data and acts as a senior penetration tester to tell you what those versions mean in terms of security risks. Cool, this is exciting. Let's see what's next to do. Okay, to verify that it's been activated, you run nmap -- version. Cool. And if it spits out a response, then it's been activated. Now we need to create the scanner script. Okay, so to create a new file, we use the command touch, which essentially, in terms of Linux, it means I need an empty file right now. The result is so we're going to make scanner.py, which is a Python file. If it doesn't exist, Linux will create a brand new one. It's much faster than opening a GUI, right-clicking and selecting new document. True. If the file already exists, touch doesn't change the content inside. Instead, it pokes the file to update its timestamps to the current time. You can also use the redirection operator, which is like the greater than symbol. It creates a blank file. But the problem is if the file exists, it will wipe it clean. So you got to use it with caution. You can also use terminal-based editors like Nano or VI. In cybersecurity, you'll often find yourself on a remote server via SSH, secure shell, where you don't have a mouse or a graphical user interface like VS Code. You must know how to use a terminal editor. Nano is a friendly choice. You'd run nano scanner.py. It opens a simple editor inside the terminal. And then you have vi/vim, the power user choice. It's incredibly powerful, but has a steep learning curve. Okay. You also have the echo command. So you can do echo. Okay. So echo creates the file and writes the specific text into one move. So it's like touch, but you essentially are writing at the same time. So you can do echo, quotation mark, import nmap, quotation mark, greater than symbol, scanner.py. If you do those symbols, it appends the text to the end of the file without deleting what's already done. You also have the cat command, short for concatenate, is usually used to read files, but it can create them too. Cat greater than symbol scanner.py. After you hit enter, the terminal stays blank. Everything you type from that moment on will be written into the file. Okay. I'm going to add this into my notes. Okay, so essentially these are the different ways of creating files. So you have touch, which creates an empty file or updating timestamps. And will it override existing content? No. Then you have the greater than symbol, which creates a blank file instantly and it wipes the file. You have code, which is heavy coding with a full graphical user interface and it doesn't overwrite existing content. You have nano, which quick edits on remote servers. No again, and echo, adding a single line of text quickly only if you use the, so it will override existing content if you use the greater than symbol, but if you use 2, it just appends to the end. Oops. Cool. So let's create the file. And let's start opening it up in a graphical user interface. Looks like I need to install it. Okay, so just took a little break while it was downloading, but now it's downloaded. So let's go again. Code. Nice. So it opens up VS Code. How should I guess you can see the whole thing. Okay, so I've got the file and folder set up. Now I'm going to start writing the code. So here is the code. I'll try and explain it to you. So the first thing that we have is the setup. Import Nmap at the very top pulls in the Python Nmap library we installed. It allows Python to talk to the actual Nmap program on our Kali system. So nm equals to nmap.portscanner in brackets creates the scanner object. Okay, think of it as opening a fresh instance of Nmap that our script can control. So I just want to see if I can show you Nmap. So the core logic, this is the most important line in the whole file. It's nm.scan inside brackets target underscore IP comma argument equals in quotes dash s capital V dash T4 close brackets. So target IP, this is the address you want to check, and SV stands for service version detection. Instead of just seeing that port 80 is open, Nmap will probe the port to see exactly what is running. Example, there's Apache 2.4.41. This is the data your LLM needs to find vulnerabilities. -T4, this is a timing template. Nmap has speeds from 0 to 5. T4 is aggressive. It speeds up the scan significantly, which is perfect for labs and capture the flags. Okay, so that was the core logic. Now, error handling. If target underscore IP not in nm.all underscore host, print host target IP is down or not responding, return none. So Nmap returns data for every host it finds. If you scan an IP that doesn't exist or is blocking your pings, Nmap won't have a host entry for it. This check prevents your script from crashing if it doesn't find anything. Okay. So return nm target IP. When a scan finishes, nm contains a massive dictionary of every host scanned. This line grabs only the data for the specific target you asked for. The entry point, if underscore name equals main. This is standard Python practice. It ensures that the scan only runs if you execute this file directly using python scanner.py. Okay. If you were to import this file into another script, it wouldn't start a scan immediately. Interesting. So the target is 127.0.0.1, which is just a placeholder for the moment. So results equals to run_scanner target is the trigger. This line is where you actually execute the scan and capture the information. You're telling Python to jump back up to the def run_scanner target IP block and passing the argument. You're handing the target, which is to that function. The run scanner function goes out, does the work, and comes back with a box of data, the Nmap dictionary. The equal sign tells Python to take that box and store it in a new variable called results. Interesting, okay. And the safety net. In programming, things don't always go to plan. The if results block ensures the script doesn't crash and burn if a scan fails. In Python, an empty dictionary or none value is considered false. If the scan failed, maybe the host was down, your run_scanner function returns none. By saying if results, you're saying only run the next two lines if we actually got data back. Without this check, if results was empty, your script might throw an error when you try to print it or process it later. It keeps your code robust and professional. And finally, before I stop this live stream, I just wanted to quickly detail what Nmap is. So Nmap, short for Network Mapper, is the industry standard open source tool for network discovery and security auditing. If a network is a large office building, Nmap is the professional inspector who walks through the halls to see which rooms are occupied, which doors are unlocked, and what exactly is happening inside those rooms. The four main pillars of Nmap: host discovery, identifying which devices, computers, servers, IoT devices are currently active on a network. Determining which ports on those devices are open. Ports are digital gateways for specific types of communication, e.g. port 80 for web traffic, port 22 for remote access. Service and version detection. Once a port is found open, Nmap probes it to identify what specific software is running and its version number. This is the gold mine for penetration testing. E.g. Open SSH 8.2p1. OS fingerprinting. By analyzing how a device responds to certain packets, Nmap can accurately guess the operating system, Linux, Windows, Mac, or a specific router firmware. In the context of your technical work in cybersecurity and pen testing, Nmap acts as the eyes of your script. Raw intelligence. Nmap provides the specific version strings that allow your AI brain to function. Automation. By using the Python Nmap library, you are automating the manual process of reading Nmap reports, something you are likely familiar with from your studies. Vulnerability mapping. In your projects, the version detection -SV is the most critical part. It allows your agentic AI to look up specific vulnerabilities related to that exact software version. Fun fact, Nmap is so iconic in the cyber world that it has acted in movies like The Matrix Reloaded and Ocean's 8 to make the hacking scenes look realistic. That's pretty cool. I'll have to look that up. The massive dictionary you saw in your terminal earlier is just Nmap's way of organizing all this inspection data into a format that Python can easily read. Nice. Okay, so far today we've outlined what this series is going to entail, and we've essentially just downloaded the requirements and we've just created the scanner, but there's a few more things that we need to do, such as cleaning the function, so like refining the data, updating the main block, and testing it. But I'll probably do that in a couple of days, maybe tomorrow, because I've got some uni classes to head to. But yeah, that's all for this live stream. Thank you very much.